no nation which expects to be the leader of other nations can expect to stay behind in this race for space.
Hello and welcome to the Terra Space Academy, where we help prepare you for a bright future in the space industry. Please don't forget to like and subscribe, and remember we have Academy gear available at the Academy store. The last few years have been a wonderful time for space science. SpaceX reignited the private space sector and is now routinely flying American astronauts to the International Space Station. Relativity built the first methane-fueled rocket to make it to space, with a successful booster flight of the Terran 1, though they'll need to work on that second-stage engine to get to orbit. And if all goes well, the Vulcan rocket system will launch itself to orbit using two BE-4 methane-burning Blue Origin engines. And perhaps sometime this month, the most powerful rocket in history, also burning methane, will launch from Texas, putting a Starship on a transorbital trajectory. Successful operation of the Super Heavy booster will make the flight a complete success, even if the Starship itself does not survive re-entry. That makes 3 new rocket systems, all burning methane, making their first flights this year. But another rocket company flying later this year might make history with a different rocket fuel. Methane is not the only clean-burning hydrocarbon rocket fuel. And today we are going to look at an innovative rocket company out of Germany that is building their orbital launch system out of propane instead. Isar Aerospace is a German company that was founded in 2018. And it plans to build the Spectrum 2-stage rocket system. The Spectrum will be fueled by liquid propane, which will be burned through the turbopump-powered Spectrum engines, with liquid oxygen as an oxidizer. Isar was named for a river that flows through the Bavarian Alps in southern Germany. The company was founded by Daniel Metzler, an experienced CEO that has co-founded several other technology startups. You'll hear more from him later in the lesson. And Joseph Fleischmann, a former project manager at the European Space Agency, with almost 20 years' experience in the space industry. He is the Chief Technology Officer. Marcus Brandl, an aerospace engineer that previously worked at Airbus and SpaceX, provided technology support. And Torsten Koenig, a space industry consultant and founder of SpaceWatch Global, which is a leading news and analysis platform for the space sector, served as the head of communications for Isar. Right now, Stella Guillen is the Chief Commercial Officer, while David Konatauer is the Chief Financial Officer, and Alexander Ohling is the Chief Digital Officer. Isar plans to manufacture 80% of their rocket systems themselves, from suppliers and tech firms around Munich, Germany. If you're going to build something high-tech from local sourcing, Munich, Germany is not a bad place to be. Isar raised $17 million in April of 2020 in Series A funding, and got an additional $91 million in December of that same year. In July of 2021, Porsche SE acquired a stake in the company, convinced that Isar would become a leading launch vehicle provider for Europe. This helped Isar raise another $75 million in a Series B funding round led by new investor ETF partners, along with participation from existing investors such as Lakestar and Airbus Ventures. In 2022, Isar won the European Commission's Horizon Prize, gaining another 10 million euros. Then other investors started signing up, and the total came to more than $180 million. Finally, in March of 2023, Isar secured a round of Series C funding, acquiring an additional $165 million. That gives Isar what they need to succeed: competent leadership, vision, technology, and funding. Isar is focused on developing launch vehicles and related technologies that can provide cost-effective and reliable access to space for small and medium-sized payloads. It is headquartered in Ottobrunn, Germany, and has additional offices and facilities in Berlin, Germany, and Lisbon, Portugal, as well as launch facilities in Andøya, Norway. Andøya offers launch inclinations of 87.4 to 108 degrees, making this site perfect for sun-synchronous and polar orbits. In July of 2022, Isar also became the first private rocket company selected by the French Space Agency to be allowed to launch from the European Union spaceport at Kourou, here in French Guiana, near the equator. Isar will use the launch pad formerly used by the Diamant rocket. The Diamant was the first exclusively French-built orbital rocket system, and the first satellite launching rocket not built by the United States or the USSR. The Spectrum rocket system is designed to carry payloads weighing up to 1,000 kilograms to low Earth orbit, and up to 700 kilograms to sun-synchronous orbit. The company has stated that the Spectrum rocket will be fully reusable, with both stages being designed to land vertically back on Earth after launch. In addition to developing launch vehicles, Isar Aerospace is also working on technologies such as advanced propulsion systems, rocket engines, and avionics. The company has partnerships with several other space industry companies and organizations, including the European Space Agency and the German Aerospace Center, to develop advanced space systems. One of those advanced systems is the propane fuel-burning Spectrum engine. Isar Aerospace has chosen to use propane rather than methane, because propane is a denser fuel than methane, which means that more energy can be packed into a smaller volume, allowing for more efficient rocket design. Kerosene, or RP1, is also denser than either methane or propane, but it does not burn nearly as clean as either of them. Propane also has a higher energy density than kerosene, 46.4 megajoules per kilogram compared to kerosene's 43.1, making it a more attractive option for some rocket applications. Another advantage of using propane is that it can be stored and transported much more easily than methane, which requires very low temperatures to remain a liquid state. Propane, on the other hand, can be stored as a liquid at relatively low pressures, making it a more practical fuel for certain launch applications. Finally, propane is a readily available and affordable fuel, which can help to keep launch costs low. Methane, on the other hand, requires more complex processing and production methods, which can drive up costs. Overall, while methane has become a popular choice for rocket fuel in recent years due to its environmental benefits and potential for in situ resource utilization on other planets, Isar Aerospace has chosen to use propane for its Spectrum rocket, based on its specific performance and logistical and cost advantages. The Spectrum engine is, again, a liquid rocket engine that uses propane as the fuel and liquid oxygen as the oxidizer. It is designed to be highly efficient, with a specific impulse of around 310 seconds at sea level. It has a thrust of around 100 kilonewtons and can be throttled up and down during flight to help control the rocket's speed and trajectory, and to enable propulsive landing for both stages. 9 of these engines will be on the Spectrum rocket first stage, with 1 on the second stage. One of the unique features of the Spectrum engine is its modular design. The engine is made up of several identical modules that can be easily removed and replaced as needed, which can help to reduce maintenance and turnaround times between launches. The Spectrum engine, like most modern rocket engines, uses the cryogenic fuel to actively cool the combustion chamber and nozzle, which allows the engine to operate at higher temperatures to increase efficiency. It seems that the European Union is recognizing that they have been falling behind in the new race to advance humanity into space. Their support of Isar Aerospace is a testament to the company's promising technology and business model, as well as the growing interest in the commercial space industry. Isar Aerospace is now well positioned to continue developing its launch vehicles and technologies so that it and the European Union can compete in the increasingly crowded small satellite launch market, and perhaps later, advance Europe to destinations far beyond Earth orbit. We will now hear from the CEO and co-founder of Isar Aerospace, as he explains why he thinks his company is a good bet for the citizens of Europe and the world.
It's fantastic to be here. I'm Daniel. I'm a rocket scientist at heart, and I want to show you why space is no longer reserved for the billionaires as a playground or the governments to do some shady and crazy stuff up there. So let's talk a little about space. Why do we do space at all? Why go to space? And I want to start with what actually do people associate with space? And oftentimes we would think about, building satellites. And this is also what the majority of the people actually think. It's like putting satellites into space. Many have actually no idea what the satellites do in space. Going to Moon and Mars is a very, very big thing, because obviously when you stand at night on the outside and you take a look at the glazing stars, you would actually see satellites, but obviously you also see the moon and the sun, etc. Now, what's a little bit more interesting is that about a fifth of people associate with aliens. Because, coming from the outside, and we actually would like to preserve our small, tiny, little, cozy planet. And then, why actually only 10% Star Wars? I think that should be more like 70%. So, space is actually not, as I said, the one playground for some tourists to go to space who have too much money in their pockets. But why we really need space is because we need it to actually manage our planet. So about 90–95% of the entire space industry really is focused on making life better on Earth. That could be anything from connectivity, beaming internet down from space, or it could be Earth observation to actually tell us when and where to harvest our crop, or how much water we actually need to put on an agricultural field. And so more and more also in the last about 5 years, what we've seen is there's plenty of startups building satellites and satellite constellations. Now, one of the questions which probably many of you, but as well as many other founders in this planet ask themselves is, how does the world actually look like in the future? And what could be my role in that? I think that in about 20 years, every device on this planet will be connected. Now, that actually might sound reasonable, but if you think that about 3.5 billion people on this planet do not have access to internet as of today, it actually is quite a challenge. Obviously, we're going to spend a lot of resources on tackling climate change. And actually, let's go a step back. Why do we even know there's climate change? It's not that. Probably if you would ask a few politicians, they would tell you, oh, there's data on the internet which tells you. But where does data actually come from? And satellites actually are generating more than half of all the data based on which we actually determine how the health of this planet looks like, what we need to do in order to make sure that we preserve it or can make it better. And over the course of the last few months, we've also seen more and more that we're already actually in a tech and talent war. And basically that geopolitical tensions are quite important, whereas over the course of the last few years, we've been living in a quite nice and calm planet. But then again, space is actually already a playground also for the militaries and defense ministries of the world. So what do satellites have to do with this? A satellite flies in space. Now the question is, where actually is space? And per definition, it is at pretty much starting at exactly 100 kilometers of altitude. Now, you can throw something up into space. I could throw up this thing up to 100 kilometers, and what would happen is the thing would pretty much exactly fall down from where I threw it up. So objects and satellites stay in space because we accelerate them to an orbital speed, which is at a low Earth orbit of about 500 kilometers of altitude, about 28,000 kilometers an hour. And that's also what we do with Isar. We build the rockets in order to accelerate the satellites. Now, if the satellite is flying at 28,000 kilometers an hour, it's circumferencing the entire planet in 90 minutes. So every 1.5 hours, you do an entire Earth rotation with your satellite, which is great, because the founders among you are thinking, oh, I can serve the entire planet with my first satellite already. Whether I gather the data in Helsinki, or in the US, or in Asia, or in Africa, it doesn't matter, because the satellite is pretty much orbiting the planet over and over and over again for many years, gathering valuable information. Now, if you multiply that single satellite and basically create a mesh of satellites such that at any point in time, you always have a satellite exactly above you, generating data or providing a service from space. You basically come up with a satellite constellation. So in the past, we've built single-off, one-off satellites. As of today, most of the companies and startups in space are building big constellations to provide a real-time service on a global scale from day one. Now, there's one single thing where, regardless of the application that you do in space, you have to go through, and that is the launch. So whether a satellite actually does telecoms or Earth observation, you have to first get the satellites into space, and this is also the role, again, that we at Isar do. Now, interestingly, and probably many of you might not even notice, is that the peace on this continent over the course of the last 7 months, luckily, has been preserved due to satellites. Because the entire communications was actually one of the first systems which was brought down from the Russians in Ukraine. But luckily, Ukrainians had access to a satellite constellations that would literally beam down internet from space with super low latencies. And you could have 200, 300 megabit per second of internet with a super small antenna about the size of a paper. Now, this obviously changes then the entire course sometimes of humanity, whereas some people do have access to space and some others don't. But the important thing is we're trying to use space for the peace of humanity and for making sure that we can actually live on this planet for longer than just the next 50 years until hopefully we're not going to destroy this planet with all our emissions, but really make sure that we create also a thriving commercial industry from it. So the entire industry is expected to go significantly to more than 3x of where we are today to above $1 trillion. We're actually already right now approaching half a trillion of revenue within the space industries. Now, if you take a look at a satellite, what you see is basically electronics. The smallest standardized satellite is just 10 centimeters times 10 centimeters times 10 centimeters. So basically, half of a shoebox. And you could literally go online right now with your phone on website of European companies and order your satellite components, get it into the basket, and order your satellite at home or to your company. That's not something which was available even just 5 years ago. Now we have university spin-offs create huge companies. Actually, ISI being here a spin-off of the university in Helsinki. And it's also no wonder that actually over the course of the last 4 years, due to that access to technology, we really have seen a major spike in satellites going to space. And again, it's not just for governments or for billionaires, but it's for startups with investors who are here and who have already successfully funded many, many satellites constellations, for example, that we really define a new operating system for planet Earth from space. Now, as you can also see, almost all satellites which were launched to space over the course of the last year were super tiny satellites. So 600 kilogram satellites, that's a little bit bigger than a fridge. And really going down to a small standardized satellites which you can just buy online. Now, what we do with Isar, we build the rockets to get all of those small satellites into space. The rocket is actually Europe's largest and most powerful privately developed rocket. We're fully privately financed, and we're designing it to carry up to 1,000 kilograms into space, whether it's for Earth observation satellites to tell us where and when we harvest crop. How do you actually measure methane or CO2 on a global scale? Again, here, you're not going to put a CO2 sensor every 100 meters across the entire planet. It's just not sustainable. But what you can do is you put a satellite into space, which is monitoring and through a hyperspectral camera detecting methane, detecting water vapor, detecting CO2. And then basically you have an overall global map. With more satellites you put into space as part of a constellation, you can increase your resolution, both time-wise, but as well as geospatially. And so you can really create a global map, which is something that we need if we really want to tackle climate change sophisticatedly and with actual data instead of just beliefs. Now at Isar, what we also do is we actually employ a rocket propellant that you have at your own home in your own refrigerator. So we use highly clean propane, which actually was quite a challenge because it's burning too cleanly. So we don't have any soot within our combustion. And so again, here, trying to make the world a better place and a cleaner place. What we believe also is that space is not going to be sustainable if you just keep building 2 rockets a year, 3 rockets a year. That's pretty much what actually Europe has been doing over the last decades. We've employed tens of thousands of people to build 2 or 3 rockets a year. And so if we really want to build that operating system in space for our planet Earth, what we need to have is launch capacity. And launch capacity comes through a lot of rocket launches at the end of the day. So what we do at Isar is we automate the manufacturing and basically take knowledge that we usually would have in the automotive industry or in the aircraft industry and employ it within the space industry. And so to give you maybe 2 examples, we can build a rocket engine from raw material to a finished rocket engine in about 2 weeks of time. Compare that to a classically designed and driven industry, where it would take them about 1.5 years to go from a raw material to a finished rocket engine. We do a lot of metal 3D printing. We do carbon fiber winding for the entire structures, such that we'll literally have 2 people in our manufacturing facility supervising the build of multiple rockets at the same time. Now, that's also not something where usually would actually think that you would get funding for out of Europe. But over the course of the last 2 years, really, we've managed to go from 0, with literally 0 experience on manufacturing, for example, to becoming probably the most sophisticated manufacturer within the space industry within Europe. So as of today, we already have a capacity with about 50 people on ground of outputting more than 10x the amount of systems and components than the entire European industry combined over the course of the last year. And so a founder or an idea can not only disrupt very small parts of this planet, but I also dare you to think big. And the next slide I'm going to show you is, because one of the biggest challenges that we had is, how do we actually get 100 million plus of venture capital financing pre-revenue? And actually, the first question that usually we got from investors about 3-4 years ago was, what did you guys smoke? And people were just completely crazy. Said, oh, you're building rockets. You're like, please go to some other. It's not part of our investment scheme. You're completely outside the box. We really like you, but it's not something for us. So at the same time, we also couldn't just go to all the international VCs and then go talk to European governments and tell, hey, you should launch your rockets with us, while 80% of our cap table actually is non-European. So we went on a challenge to say, is it possible to actually raise 100 million plus out of Europe from European investors for something that no one of them ever did actually before? And the good thing is, it does work. So even if you have super crazy ideas, don't give up on the fundraising part. We've spoken to hundreds and hundreds of investors, such that at the end of the day, we found the right ones for us, who are really bold thinkers as well. The Lake Stars, the Early Birds, who, by the way, all are here today. So big thank you to also the investors among you who believe in big and bold ideas. Now, where do we go in the future? Space is something which still today is not in the mouth of everyone. But you're already today dependent on the entire space industry, whether it's the blue dot on your phone, which guided you yesterday morning and this morning to this venue. It is connectivity, as I said, for the 3 billion people who today don't have internet access. It's also no wonder why all the big corporates are investing billions into their own space programs. Amazon, Vodafone, John Deere. Why does a tractor company use space? And so John Deere, for example, is a very interesting case because they actually already guide their tractors fully autonomously through GPS. On the other side, they're now expanding that to bring in agricultural data, have a machine learning algorithm tell them when and where to put how much water, to put how much fertilizer, such that actually they found out with half the water and half the fertilizer, if you dose it and apply it in the right way, you can actually double your output. And so what we're seeing is that many other industries are getting disrupted through space. It's the automotive industry too. How are we going to get to autonomous driving? Your car will always have to actually send up a signal of when and where it is going and where it is. Also, did you ever think about how do we find pirates? Like, these are the crazy questions we'd ask ourselves is, how do we actually know there's pirates, but also how do we find them? Again, here, it is satellite constellations, actually from European startups, who basically have a signal detected from ships, and whenever pirates would take over a ship, they turn off that signal. Now, if you overlay that data, for example, through companies like data from the companies like ISI, you can still track those ships with a radar satellite through nighttime as well as when there's clouds. But then you can actually track the pirates, and when they took over a ship, send the info to the naval coast, for example. And so space data is already today everywhere. There's no single bank transaction or no ATM withdrawal happening without space access and space data. And we're also not going to fix space. We're not going to fix climate change without space data. And so it is a super exciting industry, one to definitely look out for. But last but not least, I really want to encourage you, if you think your idea is big, think bigger. And the best thing is that it's definitely doable in Europe too. Thank you very much.
Thanks for listening and for your support. And stay safe at Astra Pro Terra.